You type a website into a browser, you hit enter, and in like a second and a half, pixels show up. That 1 second is your laptop asking a bunch of strangers a bunch of questions very politely while your data gets chopped into tiny pieces routed through multiple networks and reassembled at the other end like a high-speed jigsaw puzzle. So today, what actually happens when you type a URL, why it sometimes fails in weird ways, and how to think about internet problems like a sane person. Hey friends, welcome back to the Tyler Woodward Project. I'm Tyler. I'm a broadcast engineer by trade, a Linux nerd by choice, and I enjoy demystifying tech that's supposedly too complicated for everyday people. Today, we're talking about a deceptively simple question. How does the internet work? But we're not doing the vague, hand-wavy version. We're doing the practical version. You type a website URL like example.com, and we're going to follow the chain reaction. Why this matters? Well, once you understand the basic moving parts, you can hopefully fix the problems faster, spot sketchy behavior sooner, and make smarter choices about your home Wi-Fi, your phone plan, and even your privacy settings. And yes, there will be a couple of wait, it does what? Moments along the way, because of course there will be. This is tech. Nothing in tech is ever simple. All right, let's build the internet from the ground up, but only the parts that you need. First, a quick glossary in plain English, because the internet is basically a pile of acronyms in a trench coat. An IP address is a numeric address for a device on a network, kind of like a phone number. DNS, the domain name system, is the internet's phone book. It turns example.com into an IP address. TCP, Transmission Control Protocol, is a way to send data reliably in a particular order and, resend it if it's not in the right order or if it's lost. UDP, User Datagram Protocol, is a faster, looser way, great for things like video calls where late equals useless. And HTTPS is HTTP plus encryption, usually using TLS transport layer security, so other people can't casually read what you're doing online. Now, let's do the play-by-play. You type a URL into Firefox or Chrome or Edge and you hit enter. Step 1. Your computer checks if it already knows the answer. It looks in a few caches, basically recent memory. Your browser has one, your operating system has one, and your router might have one too. If you visited that particular site recently, you might skip a bunch of work. If it's not cached, step 2 is DNS. Hey, what IP address is example.com or MSN.com or Facebook.com or Instagram.com? Your device usually asks a DNS resolver provided by your internet service provider or whatever you've configured, like Google DNS or Cloudflare DNS or Level 3 DNS. Doesn't matter, whatever DNS you're using. Here's the part that most people miss. DNS is not the website. DNS is just how you find the address to the website. So when people say the internet is down, a lot of times the internet is fine, DNS is just having a bad day. And suddenly every site looks like it's broken because it can't translate that domain name into an actual IP address. Once DNS gives you an IP address, step 3 is, your device starts a connection to that server. If it's HTTPS, and almost everything is nowadays, it'll do a TLS handshake. That's a little negotiation where they agree on encryption keys and prove that the server is who it claims to be using certificates. That's why you can usually log into your bank at a coffee shop. Mostly. The encryption protects the content of what you're sending. It doesn't magically make you invisible, but it's a big deal. Then, step 4. The browser sends an HTTP request, something like get/, which means please send me the home page, plus a bunch of headers that say what kind of browser you are, what formats you support, and sometimes a cookie that identifies your session. Now, step 5 is the part everyone imagines wrong. Your data doesn't travel as one continuous stream like water in a pipe. It gets chopped into packets, little chunks, little bite-sized chunks. Each packet has addressing info, so routers can forward it toward the destination. Routers are the traffic cops of the internet. They don't care what your packet means. They mostly care about where does this need to go next. So, your packet takes a little trip from your laptop to your Wi-Fi access point to your router to your modem or fiber ONT out to your ISP across one or more big backbone networks and eventually into the network where the website lives. And here's the cool part. Packets from the same page load can take different paths and still arrive. TCP can put them all back together in the correct order and ask for resends if something gets lost in transit. That's why you can lose a little bit of network quality and still load a web page, even if it, feels a little slower. So, what comes back from the server? Usually, it's HTML. First, the structure of the page, then your browser sees references to other stuff like images, CSS for styling, JavaScript for behavior, fonts, maybe some ads, analytics, video. It starts fetching all that too. One page load can trigger dozens or hundreds of additional requests. And those requests might go to totally different companies on totally different servers and totally different regions. This is where CDNs come in. Content delivery networks. A CDN is a system that stores copies of content closer to you geographically. So instead of pulling an image from one server in one city, say you're in Los Angeles, but it's coming from Chicago, you can pull it from a nearby edge server, say in San Diego. Faster for you, less load for the origin website. That's why a site can work, but still feel slow. Maybe the main page loads, but third-party script host is crawling, and the whole page sort of gets stuck. Now, one more piece for the home network crowd. NAT. NAT is Network Address Translation. Most homes have one public IP address from your internet service provider, and your router shares it among your devices using private addresses like your 192.168.x.x. Your router keeps a little translation table so the replies go back to the right device. That's also why rebooting the router sometimes can fix things. You're clearing tables, refreshing connections, and forcing a clean start. Broadcast engineering hat on for a second. Troubleshooting networks feels a lot like troubleshooting live audio. You don't guess, you isolate. You check each link in the chain one hop at a time because the failure is usually boring. A bad resolver, a flaky Wi-Fi channel, a saturated uplink, or one device spewing nonsense. And that's sort of how it works. Typing a URL kicks off name lookup, or DNS, secure setup, TLS, data transfer, HTTP over TCP or UDP, and packets routing through multiple networks, often with caching and CDNs all in the mix. Let's connect this to real life with a story you've probably lived through. Why is the internet weird today? You open a site and it just spins. Another site might load instantly. Your streaming app works, but your work tools are broken. This is not you being cursed. That's how modern internet is built. Because, quote unquote, a website is rarely one server anymore. It's usually your request hitting a front door, maybe a CDN, then bouncing to an application server, then to a database, then to an authentication provider, then to some sort of analytics, then to a payment processor, then to an ad network. And yeah, any one of those could be having a bad day. Here's a common failure mode: DNS outage or misconfiguration. If your DNS resolver can't answer, your browser can't even find the IP address. It feels like the whole internet is down. But if you try a different DNS resolver, like Google or Cloudflare or Quad9, your phone, maybe you switch your phone over to the cellular network, all of a sudden it starts working. Another failure mode is routing problems between networks. The internet is a network of networks, and they share routes using systems like BGP, the Border Gateway Protocol. You don't need to memorize that name, but you should know that it's how large networks tell each other, hey, to reach these IP addresses over here, send traffic this way. Sometimes a bad route announcement happens accidentally or rarely, maliciously, and traffic takes a wrong turn. From your perspective, it looks like that one site is just down, or everything hosted on X is down, even though your Wi-Fi appears to be fine. That's why arguing with your router for an hour can be pointless if the real problem is upstream. Your house can be perfect and the internet can still be on fire somewhere else. Let's also talk about the physical reality, because people picture the cloud, and I put that in air quotes over here, the cloud like it's a fog bank. The internet is fiber optic cables, switches, routers, data centers, and yes, undersea cables. Lots of them. If you've ever wondered why international traffic can be fast but not instant, remember, you're still limited by physics. Light and fiber is fast, but it's not teleportation. And then there's the cultural piece. We've optimized society around it'll probably work. Banking, healthcare portals, school assignments, job applications, so much of life assumes a working connection, which makes internet reliability not just a tech problem, but an access problem. That's why you'll see libraries offering hotspots, schools lending devices, and people treating Wi-Fi like a utility, not a luxury. And it's also why just use your phone as a hotspot isn't a universal solution. Coverage, cost, and throttling are real constraints. One last real-world angle, though. Why do pages feel heavier than they used to? Well, because modern sites often ship a lot of JavaScript and third-party trackers. Even on a fast connection, your device still has to download it, verify it, and run it. Sometimes the bottleneck is your CPU, not your internet service provider. So if the beginning was how the pipeline works, this part was why it breaks in messy, non-obvious ways, I guess. And now let's make these issues or these takeaways into actionable items that you can hopefully learn from. Here are a few practical takeaways you can use the next time your internet acts up and you don't need a computer science degree to do this. Separate Wi-Fi from the internet. If your phone on cellular loads the site, but your laptop on Wi-Fi doesn't, that's a home network problem. Now, if both fail, it's likely an upstream or a site, the site itself. Try a different DNS. Do the DNS reality check. If everything can't be found, switch DNS temporarily to a known good resolver like Cloudflare's 1.1.1.1 or Google's 8.8.8.8 and see if it improves. If you're not sure how, searching change DNS on Windows/macOS/iPhone is usually a 2-minute fix. Reboot in the right order when you must reboot. Yes, turning it off and on again does work. Your modem, your ONT, power cycle those first, then the router, then your device. Give each step about, 30 to 60 seconds so it can actually fully come back up. Use one simple test site plus one real site. A speed test can tell you the bandwidth, but it doesn't always reveal DNS or routing weirdness. Test one known stable site and then the specific site or app that's failing. Watch for third-party drag. If a page half loads and then sort of hangs, it might be waiting on ads, analytics, or embedded content. Trying a private browser window or a different browser altogether can help you confirm it's not just a bad extension or a cache or a bad cache script. If you only remember one thing, remember this. When you type in a URL, you're not just connecting to a website. You're coordinating a chain of services, DNS, routing, encryption, servers, and caches, and any weak link can change what you experience. So, the next time you hit enter and a page pops up like magic, now you know it's not really magic. It's packets, phone books, routers, and a whole lot of engineering duct tape in the most respectable way possible. If you want more episodes like this, visit tylerwoodward.me. Follow at tylerwoodward.me on Instagram and Threads, and subscribe and like the show on your favorite podcast platform.